Through stuff here. I think I counting today, we have 5 classes left. Counting today, we have 5 AP Calculus meetings.
We're single digits.
So, a couple of things. If you haven't finished filling out the end of the semester survey that's on the class page on My Notre Dame to let me know whether you want a double or a retake, please do that here in a timely fashion, particularly if you're planning on a retake, so I have time to make sure everything is ready. Today we're going to go through the rest of the multiple choices and start the first, the calculator free response packet. Next class, I'd like to finish the free responses. So Wednesday, I have a review game to play, where you have an opportunity to improve your grade based on your performance on the review game. And then we'll figure out what to do the last 2 days.
Party. Yeah, party. Party.
We can do all the part E's from every exam. That sounds great.
That was not musically.
You said part E.
No, parties. Party.
Part E, yeah, got it. Would you prefer the part A's?
Stop.
I didn't find that very funny.
I know, but that's why I laughed, is because nobody else liked it. You're like, ugh! Stop. So we're finishing up with the no calculator multiple choice packet. This is packet A, multiple choices without calculator. So this is the one we were working on last time. We have 2 more questions, both of which I highlighted as they were both had lots of guesses and poor correct responses. So both of these are both ones worth talking about. Then we'll move on to the calculator packet part B. So this is number 29. You should all feel a little embarrassed because this is basically an Algebra 2 question. So it says, which of the following functions has exactly 1 horizontal asymptote and no vertical asymptotes? Where do vertical asymptotes, how do those occur?
The denominator.
Denominator equal to 0. Which one of these can not equal 0 in the denominator? A has no solution because x squared plus 1 equal to 0 has imaginary results. And D, because e to the x equals -1, I know exponentials can't equal a negative value. So you know that right away we can get rid of results B and C because both of those can have 0 denominators, right? B, if x is -1, you get a 0 denominator. C, if x is 0, you get a 0 denominator. So those have vertical asymptotes. We don't want them. Cool so far? All right. Horizontal asymptotes. For a rational function, which is what you have in response A, when do we have a horizontal asymptote? This is an Algebra 2 question. Great. Degree denom, except it's greater than or equal to the degree for the num. Well, that happens here, right? So that has just either y equals 0 or y equals the leading coefficient over the leading coefficient. Either one, doesn't matter. That's exactly 1 horizontal asymptote. That's our result. This guy you might recognize as a logistic curve. We talked about that last year. So you have like 2 horizontal asymptotes. It's like that S-curve guy. So needed no calculus at all to do this. If you wanted to, you could look at the limits as x approaches positive and negative infinity for each of those. You'd get different answers. But I think that's a little bit of overkill. I'm going to rather rely on previous knowledge to do this question. rather than any kind of calculus. Is that cool? All right. 30. Looks like a mess, right? It's a 10-second question. If you knew what to do. So it says, for a certain continuous function f, the right Riemann sum approximation of the integral from 0 to 2 of f of x dx with n subintervals of equal length is 2 times n plus yada, yada, yada for all n. What is the value of that integral? So the trick here is remembering the limit definition of an integral. Right? Now, vocab. That tells us that this thing is that. So it really just turns into evaluating that limit. This is a polynomial over polynomial, right? So all I really care about is the degrees. What's the degree of the numerator? Good. It's going to be degree 2 in the numerator, and the degree in the denominator is 2. Since the degrees are equal, it's just leading coefficient over leading coefficient. The leading coefficient in the numerator is 2 times 3, and the leading coefficient in the denominator is obviously 1. It's 6. If you knew what we're looking at, like a 10-second problem, and just like, okay, just the limit of this. It's an easy limit to do, and I'm done. It's like a 10-second problem if you knew what to look at, or knew what you're looking at. Now, recognizing what you're looking at is difficult, but this is a familiar phrasing, right? Once you see that, like, oh, okay, this is just a limit problem, where I'm just taking the limit of the sum formula that they're giving me. Okay, easy enough. All right, take out your other multiple choice packet, packet B. I'm going to start by reading through the correct solutions, and then I'll deal with some selected answers. Again, I just picked the things that either were frequently incorrect and or frequently guessed. That was my criteria for picking. But before I start going through stuff, I'm going to read through the correct responses so you have them. Are you guys ready to roll? 76 is dog. 77 is boy. Yes.
Wait, 76 was what?
Dog and then boy. So DB were the first two nulls. 78, cat. 79, boy. 80, ace. 81, dog. 82, dog. 83, cat. 84, dog. 85, boy. 86, cat. 87, boy. 88, cat. 89, ace. 90, cat. Any repeats? 4 wrong is really good. If I'm getting upwards of like pushing 70%, I'm very happy. Anytime I'll take those all day long. All right. 76 was pretty good for the most part. Got lots of correct responses there. We'll go to 77. This says, let h of x be the antiderivative of yada, yada, yada. If h of 5 is equal to pi, then h of 2 is equal to. This is a fundamental rule of calculus part 1 question. It's just saying that, like, oops. Right? Just saying this. That's the fundamental theorem of calculus part 2. Is how you do a definite integral. So for us, we're told that the derivative of h is this thing, because h is the antiderivative of it. And we want to evaluate this from 2 to 5, because we're interested in h of 5 and h of 2. That is something we can just type into our calculator. And that's pi. So we just do some like algebra 1 algebra at that point to solve for h of 2. Oh my gosh, is that it? That's it, man. I will guarantee you at least once, but probably more than once, this technique will be needed in your AP exam. They are 100% going to give you questions, probably plural, where all you really need to do is recognize I used the fundamental theorem of calculus part 2 here to solve for the missing piece. Super common, super common question format. Be looking for it. Everybody's okay with that? The trickiest piece of this is they said h is the antiderivative of this, rather than saying like h prime of x is equal to that. Maybe if they said h prime of x is equal to that thing, would have occurred to more of us what to do, maybe. But those are equivalent statements. All right. Let's do 78 next. So it says the continuous function f is positive and has domain x greater than 0. If the asymptotes of the graph are of f are x equals 0 and y equals 2, which of the statements are true? So I'm going to try to sketch a picture here. So I have that. And we're told that the graph is has a domain greater than 0 over there and is positive. So it has to be here. So my graph has to look like that then, right? Everybody cool? Yeah. So if I look at this piece here, this says as x approaches 0 from the right, y is going to positive infinity. So I'm looking for making sure, like this one's out because there's no x approaches 0 from the right. This one's out because x approaches 0 is not going to positive infinity. I eliminated two choices right away just by looking at the first arrow. This arrow, x approaches positive infinity, y approaches 2. That's this one. And again, anytime I can get down to a 50-50, even if I don't know what to do after that, I am pleased with my progress, right? If I can 50-50 the whole way through, like that's pretty good. I'm pretty happy if I have to guess at a 50-50 rather than a 25. A 1 in 4 guess is way worse than a 1 in 2, right? Give me those 50-50s. Again, this, your calculator would have been worthless on, right? Completely unnecessary. Could have been a part 1 question, a no calculator question. The previous one would not have been, right? Like you definitely needed your calculator to do that integral. Like you weren't doing that thing by hand. They would never ask you to do something that complicated by hand. 79 was good. I'm going to skip it. 80 says the function f has the first derivative given by yada, yada, yada. On what intervals of the graph of, or is the graph of f concave up? So how do I tell if f is concave up? Great. The second derivative has to be greater than 0. So what I'm going to do is I'm just going to graph the second derivative of this on my calculator and look at the picture. So again, you could do this by hand, but check this crap out that I'm about to show you. This is like the greatest thing ever. So what I'm going to do to graph the second derivative is I'm just going to type in the first derivative into y1. If you have your calculator with you and you want to follow along, that is okay. But this thing I'm about to show you is pretty sweet. And now I don't want to look at the graph of f prime, so I'm going to turn that off. Now to get the graph of the derivative, now I could do this derivative by hand. It's not a hard derivative to do. But what if the derivative is a pain in the butt? The calculator can do it for you. Let me show you how. So if I press the math button and use command 8, and I press X here, and then I do Y1, and then I do X equals X, and then I'm just going to graph this on the standard window. I suspect it'll probably be enough, looking at my responses. So that's the graph of the second derivative. Where is that greater than 0? 2 to infinity. Boom. Did 0 calculus. All I had to do was recognize, like, what information do I need to answer this question? Calculator, give me that information. That's what I would recommend. Much easier than even doing the second derivative by hand and risking like 2 times 3 is 5. Or dropping a negative sign, or saying the derivative of -3 is still -3 and not 0, right? Let the calculator do it so that there's no mistakes that can happen. We want every one of those little extra points we can. Don't give them up because we did something silly, and let the calculator handle it. All right. 81 was one of the 2 hardest questions based on your correct responses. This, again, is your calculator is worthless for this question. Will not help you. So here it says the graph of the function f is shown above for -2 to 2. Which of the following could be the graph of an antiderivative of f? So like when we did antiderivative of f, we used like cap f, right? But the way I would think about that is that this graph is f prime, and what I'm going to be looking at is the graph of f. What am I looking for when I look at the derivative to figure out what's going to be happening with the antiderivative? I'm looking at where it's 0. What is the 0 is going to tell me? It's going to tell me local mins and maxes, right? So how many extrema should f have? Just 2. If I look, this one has 3 extrema, it's out. That one has 4. That one has 4. D's the only one with 2. I'm not thinking about any harder than that. I'm moving on. Whoa! If there were 2, I notice that this is negative to positive, so that is a local min. And this goes from positive to negative, so that's a local max. I could use that maybe to tell the difference if you had 2, like if you had the reverse of this, the reflection of this graph as another option, like how would I tell the difference between the 2? I would just use the graph then to determine which one is the min and the max, and that should do it. What do you guys think? Not bad if you know what to look for, right? If I have a graph of a derivative and I'm trying to find the graph of the antiderivative, I'm starting with the zeros and making sure those match up for the extrema on the antiderivative. Easiest thing to do to start. Not worrying about slopes. It's too hard. Just look at those, look at the critical points and then count your extrema, do some elimination. Even if I get down to 50-50, again, I'm super happy to do that. If I have to guess after that, I'm not devastated. Still feel pretty good. Is everybody okay on 81? You see the strategy on something like this? Again, super common multiple choice question. Here's a function. Here's some antiderivatives. Pick the graph that it could be. All right. 82. So 81, only one person between the classes that filled out the form got correct.
Really?
Yeah. 82, only 2 people got this one. 82, only 2 people that sent me back their answers got this one correct.
Yeah. Well,
So 82 says a particle travels along a straight line with velocity v of t equals yada, 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 meters per second. What is the total distance in meters traveled by the particle during the interval from 0 to 2 seconds? How do I do this? Go ahead.
you have to find where it flips from being positive to negative, and take the interval where it's all positive and add it to where it's like all negative.
So essentially I'm doing this integral, right? I'm just doing that in my calculator. The calculator can do that for me. I don't have to show any work. Way easy. Again, what you said, 100% correct. But because this is a multiple choice, I don't have to show work. My calculator has an absolute value button.
Where is that?
Let's show you.
Yeah,
I have no
idea.
If you go to math and then it's like number and then
Yeah, something like that. Yes. So again, I'm just typing this thing in to y1. And again, you could do it directly in the line when you did the integral. That would be okay also. But I like doing it this way. So math, number 9, to get my integral from 0 to 2. And then for the absolute value, do math. I go over to the number tab. First option is ABS. That's for absolute value. And then do math, y bars, y1, dx. Enter. Dunzos.
I always wondered what that is.
It's not your stomach muscles.
It's your car brake.
So there you go.
That's really helpful.
But this is part of why we do this in advance, to find out, like, oh, I didn't know about that trick. Oh, I didn't know the calculator could do that. Oh, I didn't know, like, because it's hard for me to go through and show you like every single thing with the calculator. A lot of it's just like, oh, cool. Like I didn't know we could do that, or I said it and then maybe you just missed it that day or whatever. Because that happens too, right? 83, 84, and 85 were all pretty good, so I'm going to skip those. 86, we've done already. This was I know this got put in, yeah, sure. I know I put this in one of the multiple choice problem sets. So says the twice differentiable functions f, g, and h have second derivatives given above. Which of the functions f, g, and h have a graph with exactly 2 points of inflection? How do I find an inflection point? And,
Switches from positive to negative.
or vice versa, right? Right this way. Yes, so you could graph each one of these and check. What if this was a no calculator problem? Because they do not need your calculator to do this. Here's what you do. You look at this one. What is the degree of that polynomial? Degree 1, degree 2 times degree 3, that's degree 6. What's the leading coefficient? Positive. So I know that it's going to, the end behaviors are going to look like this. What are the zeros going to be on this polynomial?
0, 1, and negative.
So I know we have something like that going on, right? Go back to your algebra 2. What type of, how does the graph cross at that 0? Because there's a multiplicity of 3. It has that like bend thing going on. And then how does it cross when the multiplicity is 1? Straight through. And then how does it cross when the multiplicity is 2? Bounces. So if I look at this, I have 1 inflection point, 2 inflection points, not an inflection point though, because there's no change from negative to positive or positive to negative. So there's 2. So I know F has to be one of the answers. I can dump those 2 right away because F was not included. Now, if I think about this, what's the difference between F and G?
One starts up.
Yeah, I've just shifted the entire graph up 1 unit, right? So that's G would look something like that then, right? How many inflection points does it have? 2. So that one needs to work. And if I do orange or something, if I do H, that's just going to shift it down.
And that would have 3, right?
Oops. Well, probably, let me do that one more time. It's going to have 4 actually, right? 1, 2, 3, and then 4. So again, you could do it with no calculator. It takes a minute to get your graph of F, but once you have that, you can just eyeball what's going on, thinking about shifting up or down. It's not so bad. So F and G only should be our answer there. Cool. It's nice when we connect it back to the stuff we've already done, right? When it's just like, oh, that's foundational stuff. Like, I kind of remember that. It's good to remember. That's why I would need that. It's good to remember, right? Like, let's review it now. But again, if this is on the calculator section, you're exactly right. Just graph the 3 of them and just look with your eyes. No problem doing that. Cool. 87 certainly could be done with no calculator. So it says the table above gives values of a function f at selected values of x. If f is twice differentiable on the interval from 1 to 5, which of the following statements could be true? So I'm just going to look at the slopes. So f prime is certainly negative, right? Because those all have negative slopes. Let's look at whether these are increasing and decreasing now. So I notice that from each one, the slope increases by 1. And I'm done. That's it. Again, if you know what to do, you know what to look for. You've seen this type of problem before. it's quick, right? It's quick. There very rarely do you have a problem where it's like, that's a legit like 3-minute problem in here. We have yet to run into one of those. They've all been, in all reality, the hardest ones in here were faster than the hardest ones from the no calculator multiple choice. A couple of those were kind of doozies when you had the separable differential equations. Took some doing to get through some of those. We've yet to run into something that nasty here. And I may go back and look at those and see if I can find a hack through that for you guys. Okay, 88. This, although surprisingly large number of you guys got correct, was the most guessed question also. So let's go through how to do this. So it says, let f be the function defined by f of x equals yada, yada, yada. Let g be the function defined by g of x equals yada, yada, yada. The line tangent to the graph of f at x equals 2 is parallel to the line tangent to the graph of g at x equals a, where a is a positive constant. What is the value of a? So parallel means they have the same slope. How do I find the slope of f at x equals 2? F prime of 2. So that has to equal then the slope of g at a. How would I write that? I'm going to solve this now on my calculator. Not going to do any of this by hand. Now you could, but let's not, right? So into y1, I'm going to type in my f of x. And in y, and I'm going to turn that off because I don't want any of that to graph. And in y2, I want to just graph. Well, I unhighlighted the equal sign so it doesn't graph it. Yep. And then into y2, I'm going to type g of x. And I'm going to do just the general derivative of g of x. So math 8 d dx. And now I'm going to do that on y3. And I'm going to have x equals x because I want that to be arbitrary. Looking at my numbers here, I can change my window to just go from like 0 to 1. And that ought to be good. Maybe I'll change this to be like -3 to 3 or something. I suspect it'll be not tremendously big. Yes, sir.
What did you put as your x for y4?
X.
Oh,
so if you want the general derivative, if you don't want a specific number, you put an x there, and then it'll turn it into a function in terms of x. Oops. But I forgot to not graph that other piece. Oopsie daisy. So see how I have the extra curve there? I forgot to turn off that graph. Okay. Do it again. Isn't this lovely though? Like no algebra, no calculus. I just have to know like enough about calculus to do the setup, but the calculator is going to do all the heavy lifting for me, which is lovely, right? Like makes it so much easier not to make like a really critical mistake. So I'll just find the intersection of those two, and I get 0.447. What do you guys think? Yeah, that's something you have to use your calculator for because you'll end up, no matter how you're doing it, you're going to have a yucky thing to solve that you probably couldn't without a calculator. In fact, I know you couldn't with the kooky decimals. 89, again, one person that responded to the survey got this correct. So this was the other hardest problem on here. And this one, again, this could be a part A question. There's nothing your calculator is going to give you that can help you on this. So it says, let f be a continuous function for all real numbers. Let g be the function defined by g of x equals the integral from 1 to x of yada, yada, yada. If the average rate of change of g on the interval from 2 to 5 is 6, what is the, or which of the following statements must be true? What does average rate of change mean? No. It means slope. Average rate of change is slope. Instantaneous rate of change is a derivative. So this is just going to be g of 5 minus g of 2 over 5 minus 2, and that equals 6. That's what that statement would be saying, symbolically. Everybody's okay so far? Now we know what g of x is. So if we put that in, that's going to be g of 1 to 5, f of t dt, minus g from 1 to 2 of f of t dt. Everybody's okay? What does the integral from 1 to 5 of f of t dt minus the integral of 1 to 2 f of t dt equal? See if you can, I'll write it down to how we get there, but can anybody see it without having to have me just intuitively? Yes, it is just the integral from 2 to 5. Let's show you how. Great job. So I can break the integral from 1 to 5 into the integral from 2 to 5 plus the integral from 1 to 2, right? That's one of my integral rules that I can use. Those guys cancel out. And you recognize what this means. The average value of f on the interval from 2 to 5. That is exactly what that means. That's just the definition of the average value of a function. Yeah, no rush. We're doing great on time. And again, everything that I'm writing here is in the OneNote. So if you ever want to go back and look at what I did, it's all in the OneNote. We're recording what we're talking about right now. So if you want to go back and rewatch it, it'll be there for you. But this one is one that I read and I'm like, I don't have any intuition right off the jump as to what, even eliminating one of these choices, like, I don't know, like, I had to sit there and like, okay, what does that statement mean? Let's start with that. Okay, what can I do with these g of 5s? I have a thing for that. Took me a second to look at when I put the integrals in, what to do with it. But we got there. And again, this is a pretty familiar presentation. I've gone through like all 3 of these multiple choice things, and I think I've seen something similar to this pop up on a different test. I've been working my way through these 3 practice tests that I have for you guys. I think I've seen this one or something similar to this happen before. And And 90 was okay. I think you guys was pretty correct, and there weren't a whole lot of guessings, as it's mostly just like definitional. Again, this one could easily be a no calculator problem. Was there anything that we didn't do that you personally would like to see done? Because again, I skipped around through these two multiple choice pieces and just targeted the things that were the least correctly answered and the most guessed on. But if there's something else that you're like, yo, I looked at this and I was like, I thought I was making some progress and I got to the wrong spot and I don't know what happened and we didn't talk about it yet. Can we talk about it? Happy to do it. So take a minute if you want. Pierce.
Can you just scroll back up?
To 89, you wanted to write some more stuff down?
Yeah.
Absolutely. No problem. Prates, what do you got? Oh, okay. You just, when you did your U sub, you just goofed the derivative or whatever?
Yeah. Well, I wrote it down right when I picked my answer.
That's frustrating. I have to laugh at that because that's the exact kind of mistake I would make. So, like, I feel your pain on that, and there's nothing to do about it but laugh at yourself. Go, gosh, I'm dumb. It's like, what was I thinking there, Mr. Kulik? Pierce, are you good?
Yeah, I'm all good.
Okay.
Did we do 6 on the?
We should have. Let's see what I had written down on it.
Yeah, we did.
Okay. Yeah, because it was just the slope problem.
That's just as slope. This reading is average rate as slope.
Yep. Yep, that's all you needed there. All right, should we go on to the FRQs? We're going to look at the calculator FRQs first. As I go through and look at these, I'm going to tell you like how many points each part was worth and what the grader would have been looking for in assigning the points or scoring your particular question. This was the same thing I used to do when I wrote down the points on your problems on your pages. So like if you saw +1 all over the place, it was for those specific, I was looking for the specific things from the scoring report on how to grade the problem. The same thing your AP grader would be looking at. So number 1 says a particle moves along the x-axis. So the velocity at time t is given by v of t equals yada, yada, yada. At time t equals 0, the initial position of the particle is 7. Find the acceleration of the particle at time t equals 5.1. This is a 1-point question. The only calculus thing you really need to know is the relationship between velocity and acceleration. What is that relationship? The acceleration is the first derivative of velocity. So all I would write down, all the work that you would need to do is write that. So to find that v prime of 5.1, I'm using my calculator. Yeah, I saw several of you guys try to do this by hand, and it is a mess. Yeah, it is a mess. That quotient rule is not fun because there is a whole lot of foiling going on there. You should, in the calculator parts, do nothing by hand. Use your calculator to do all of it. Even if the derivatives are easy, let the calculator do it. So I did that. I typed it into y1, and then I do math, command 8, ddx of y1 when x equals 5.1. So 6.49, that's it. And technically this would be, it doesn't give us any units, so I wouldn't even worry about it. It's a 1-point question. They wouldn't even be worried about units anyways. If all you wrote on your paper was 6.49, I think you'd still get the 1 point. My notes say just 1 point for the answer. But that is enough work either way. Even if it was a 2-point problem, the only way they'd assign a second point is if they asked for a unit with correct units. Hi, Isaac.
I'd like to go water bottle.
I didn't notice anything. You're free to come and poke around. No problem. See you later. Everybody good on this one, though? Use your calculator. On the calculator parts, use your calculator. All right. Part B says find all the values t in the interval from 0 to 2 for which the speed of the particle is 1. Notice here they said the word, what word in here is the key word? Speed. They said velocity before. What's the difference between speed and velocity? Are they the same thing?
One's in a direction.
Yeah, so if you're walking forward at 1 meter per second, that's speed of 1, velocity of 1. If you're walking backwards at 1 meters per second, that's speed of 1, velocity of -1. So what is speed in relation to velocity?
Speed is absolute value.
Absolute value. Very good. So we'd be solving for that. Writing that down on your paper is 1 point. 2-point problem. Or if you wanted to, you could solve for you could do that and write that as well and solve both of those equations. That would be acceptable also. It's equivalent statements. I would just do the absolute value one. How am I going to solve this equation now? I'm going to graph it on my calculator and find the intersections. Mr. Kulik does no solving by hand when his calculator is available to him on an AP exam. I straight up shouldn't have cleared that answer because I needed that still. I don't know why I did that. I was talking and not thinking. That's the power or the beauty of writing it into the Y1 is I don't have to retype it every time I want to use it. You guys, like the calculator part, you want to bank some points because these questions typically are still worth the same 9 points, and all you got to do is get stuff set up. So to do this, I'm going to do like math, absolute value, and I'm going to do that to Y1 so I don't have to type it again. And then I want to do 1. Oops. And I want to get that out of there. And I just need to graph this from 0 to 2 because it only is worried about the time 0 to 2. So here's my absolute value of velocity coming in. There's my line. I see I got 2 of them. So second trace, intersect, enter, enter, enter. And I get 1.40 for one of them. Second trace, intersect, enter, enter. But the third enter, for my guess, I got to move it close to the one I haven't found yet. So I got to move that guess over there. And I get 0.772. That's your second point, is the 2 correct answers. Again, if you knew what to do, not taking too long, right? Like, use your calculator, let it do the heavy lifting.
Oh, wait, do you mind if I copy that answer stuff?
Oh, yeah, go ahead. This is all going to be like, it's all in the OneNote also, right?
Yeah.
But yeah, I'm happy to pause for a minute.
Thanks.
No problem. You good?
Okay, yeah.
Okay.
Thank you.
Yeah, no problem. For part C, this is a 4-point problem because it's actually asking you to have to do quite a bit. It says, find the position of the particle at time t. Is the particle moving toward the origin or away from the origin at time t equals 4, justify your answer. So let's start by finding the position first. Calculus question. What is the relationship between the velocity that you're given and position? It's their antiderivative, right? So I'm going to say x of t is my position. So it's going to be some constant plus the integral from 0 to 4 of v of t dt. Notice I don't need the absolute value around velocity here. Why don't I put the absolute value around velocity? Because it asks for position as opposed to distance. Is everybody okay? How do I solve for c? Oh, well, I guess I should say, if I'm doing that, this should be t, but x of 4. How do I solve for c? It's very easy.
T equals 0, the initial solution of particle 7.
So 7 is c. So acknowledging that the integral of position, or the integral of velocity is position, that was one point. Acknowledging the initial position is 7 was a second point. Getting the actual answer out of this now is a third point. So I just would type this into my calculator. I'm not going to do it by hand. I'm just going to write down the numbers. Everybody okay with that? That's the third point. The fourth point is going to be deciding, is this moving forward or away or toward the origin? So let's think about what's happening. So the origin's here. We started here at 7. And then we end up here at 6.712. So depending if the particle is now moving forward, we're going away, or if it's moving backwards, we're going towards. Everybody agree? How can I tell whether it's moving forwards or backwards? What quantity is going to tell me that? What's it? Velocity. Which velocity do I want? At time 4. T equals 4 is the time. So I just need to find out what v of t equals, and that'll tell me. Yes? So how am I going to find v of t, or v of 4 on my calculator? I'm just doing y1 of 4. Velocity was the function that was given to me. That's positive. So we are moving away from the origin, yes? Of course. So I would say I'm moving away from the origin because the position is to the right of the origin and the velocity is positive. This would have been your last point. Notice that you needed to calculate v of 4 to do that. So I think if you stated that without the velocity, I don't think you would have earned the point, or without at least stating the velocity being positive or negative. I don't think you would have needed the number. I think just stating a positive or negative would have been enough.
Did you say velocity was positive?
Yes.
I said it was moving away. Velocity was positive.
Oh, I might have been confused at what you did.
Gotcha.
Yeah, it could have just been I made a mistake, and like some of our work was a little bit scattered, and I was trying to just like crank them out because I wanted to get them back to you so I had time Yeah. My apologies then, if I goof that. All right. The last part here, again, there's 9 points for every free response question. We've done 7 of them, so this last one must be 2 points. It says, during the time interval from 0 to 4, does the particle return to its initial position? Give a reason for your answer. So at t equals 0, we're at 7. At t equals 4, we're at 6.7. So if we did this, the answer is yes. If we did this, the answer would be no. Everybody agree? So what I want to do is I want to check, for some t that's close to 0. Maybe just like at t equals 1. Let's check the position. All I need to do is find a position that's greater than 7, and I have enough to complete my answer. So if I do x of 1, 7 plus the integral from 0 to 1 of v of t dt, I get 9.4. So what I found is that is what's going on, right? So what theorem can I use to show that along the way I have to cross 7 again? Okay, so how do you know it's continuous? Okay, so I know that since x prime of t is equal to v of t, and v of t is, that implies that, okay, so that implies x of t is differentiable, and that implies x of t is continuous. So I would say it's not the definition of function, but it's the intermediate value theorem. So I would say by the intermediate value theorem, since x of 4 is less than 7, which is less than x of 1, there exists some c on the interval from 1 to 4, such that f of c is equal to 7. So you would have gotten 1 point for being able to create that sandwich. And then 1 point for your explanation. But you needed to have that continuity argument in there to be able to use the IVT. I don't think they would have given you the argument without that continuity piece. How we doing? Does this help kind of walking through what you're thinking to do these problems and what's the key idea here? How can I use you take advantage of my calculator? What can my calculator really do for me? Yeah, I thought this first question was quite easy. This one I thought there's one part that's tricky to it, and if you can get past the tricky part, the rest of it's okay. But if you don't catch on to the tricky piece, it's that sucked. All right. Question 2. During the time interval from 0 to 4.5, water flows into tank A at a rate of A of t equals yada, yada, yada. During the same time interval, water flows into tank B at a rate of yada, yada, yada. Both tanks are empty at time t equals 0. The graphs of A of t and B of t are shown in the figure above. They intersect at the points t equals k and t equals 2.41. How much water will be in tank A at t equals 4.5? So, oops, let's say C plus. So the water in tank A at time x is going to equal C plus some constant plus the integral from 0 to x of A of t dt, right? What is the C in this case?
0.
0, why?
That's zero.
Both tanks are empty at time t. Boom. So that would be 1 point. Typing that into your calculator and getting the answer of 66.532 liters. That would be your additional point. I don't think this doesn't say that you need to have the unit. I think if it doesn't say with proper units, you will not be graded down for the unit, is my understanding. But I would try to be in the habit of writing them down because it's an easy thing to forget, because it's usually the last thing on the question. You did all the hard work and then you forget a unit because you're used to not writing them. And it's like, left a point on the table. All right. Part B is the part that if you didn't figure this piece out, I don't think you could have really done the rest of this, which is kind of crappy, and I don't see that happening very often in the later FRQs. I think they go through and try to be really diligent about not kind of stacking the parts of a question. So if you can't do part A, you can't really do part C and D afterwards. So it says during the time interval from 0 to k, water flows into tank B at a constant rate of 20.5 liters per hour. What is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? So, if I look at my problem, so this is k right here, right? So the amount of water, the difference in the water between the two tanks is that area, correct? So the water in the tanks at time x or at time k is just going to be the integral from 0 to k of what was it? Which one was on top there? It was the b of t minus a of t dt. So 1 point for doing that. Now, in order to do this, to actually find the amount of water, we need to figure out two things. We need to figure out what number k is, and then we have to figure out what is the function for b of t. Because it does not give me a function for b of t in the problem, right? Guess what? Read this problem again. Read that first sentence again. The water flows into tank B at a constant rate of 20.5. What that tells me then is B of t equals 20.5 as long as t is less than or equal to k. So that's what I can put in here for B of t. Okay. How am I going to solve for K now? Yeah.
We put in 20.5x and then whatever A of t is into a calculator graph and how do they intersect.
Not 20.5x, just,
20.5.
yeah. Because it says it's a constant, not at a constant rate. Well, okay, flows into tank, but B of t is the rate function,
Oh.
right? The rate of B of t. So yes, so we're just typing that into our calculator and finding the intersection there. That's exactly what we're gonna do. So here's my A of t function. And that's I thought was the trickiest part, was recognizing what you had there, right? Okay. And now the window I'm going to pick for my calculator is just going to be the window that they gave me on the graph here. Oops. Yuck. Come on. So there's my A of t. Looks just like the picture they gave me. Here's my 20.5. I'm just interested in that first intersection. Oops. And I get, oops, gotta be careful there. That was the wrong spot, right? Enter, enter, and then the guess, I have to move closer. So I get 0.892. Oh, come on now. So 1 point for this, and then now I've got it to a point where I can type that into my calculator, right? This part was B of K, or B of T, right? This is B of K, right? So that answer turns out to be 10.6, and that's the third point, just for the answer. That was the hardest part because everything afterwards needs that value for K. And if you didn't figure that out, if you missed that tank B at a constant rate of 20.5 means B of t is equal to 20.5 up until K, and you couldn't solve for K, I don't think you could have done the rest of this, or gotten very far anyways. There are a couple of points you could have scrimped out of here. Part C is 2 points. So it says the area of the region bounded by the graphs of A of t and B of t between K and 2.416 is 14.70. How much water is in tank B at time 2.41? So we're told here, if I go back and I look at my picture, I can see that B of t is on top of A of t between those two values, right? So we're given a value for this section. Everybody agree? That's what the thing told us in the question. So we know that the integral from K to, actually I'm going to write the number for K. And then B of t minus A of t equals 14.470. Is that okay? Oh, sorry. I had the, yep, you're right. Had those in the, I said the wrong thing. Yes, 100%. Yeah, the one that's on top should be in front. 100%. So, if I do this, oops. And that's something I can type into my calculator because I have a of t, the function is given to me. If I type that into my calculator, I get 44.497. That was worth 1 point coming up with that. So with a little bit of algebra, I can see that the integral from k to 2.416 of b of t is 30.03 or something. How do I find the integral from 0 to 2.4 yada 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 for b of t? Yes, yes. So I think about it this way. So this is my 3003, and this is going to be 20.5 times k. Yep, I'm going to zoom in a minute. And so that answer of, where is it, 48. Point, yada yada, 314. That was our second point. Kind of feel like I would have added, if it was me doing the scoring, I would have taken 1 point from question A and put an additional point on question or part C here. Since A, all you really had to do was do the integral on your calculator. I don't know why that got 2 points and this one only got 2 points. I thought this was much more involved than part A. But that was the idea. All right, last one, part D. This has also got we've done a 2, a 3, and a 2. There's only 2 points left for this one. So it says, during the time interval from 2.7 to 4.5, the rate at which water flows into tank B is modeled by W of t equals yada, yada, yada. Is the difference W of t minus A of t increasing or decreasing at time 3.5? If I want to know if something is increasing or decreasing, what do I need to look at? First derivative. So all I need to do is look at this. 1 point for writing that down. 1 point for typing that into your calculator and getting the answer to come out. I must have messed up. Give yourself another point. You enjoy. So again, to do that on my calculator, I have A of t already in. So I'm just going to type in my W of t. Because I am not doing any derivatives by hand. on the calculator section. So I'll just do y2 minus y1 at 3.5. So I get negative 1.14. That's less than 0, so decreasing. Bam. I was, my mistake here. You needed the answer to that, and then to conclude it was decreasing. My mistake. So if I didn't give you maybe a point, maybe it's because you didn't do all the way to the less than 0. Yeah, I took a second read of this, and I was like, oops-a-daisy. You needed the negative piece as well. Yeah, you do so much better now that you realize that, like, I shouldn't do anything by hand on this section. Hands, take a break. It's calculator turn. Oh, we're going to stop here for today because I don't want to get into the next section with just a couple minutes left anyways. Like, who cares? So, how you guys feeling as we're going through stuff? Like, feeling like, okay, I've got all my silly mistakes doing this for the first time kind of out of the way here. I'm getting a better idea of like how to read these things and like what to look for. What are some familiar problem types? What are some definitions that like maybe I was a little unsure about or a little shaky about that I feel much better about? Hopefully this feels much better a second time through. If you want to try a second time through, I'm going to post in the 2018 practice test that you can start working on. My advice to you is to try to spend a little bit of time every day doing a little bit of calculus practice. Okay?
Good afternoon, Notre Dame.
No. One moment, I'll talk a little bit more.
To stop and reflect on our day. God, where did I see your power at work today? Dear God, I thank you for being ever present in my life and the lives of others. Please compel me to notice your power at work more often. I ask this in the name of the Father, the Son, and the Holy Spirit. Amen.
Again,
have a great afternoon, Notre Dame. God bless.
Try to do a little bit every day till the test, like a half an hour, especially on days that you don't have class, a little bit of studying